This program is a presentation of UCTV for educational and non-commercial use only.
Welcome to A Conversation with History. I'm Harry Kreisler of the Institute of International Studies. Our guest today is Dr. Jacques Bouchard, who is a special advisor to the chairman of the Atomic Energy Commission of France. Dr. Bouchard, welcome to Berkeley.
Thank you.
Where were you born and raised?
I was born in Dijon, which is, as you know, the capital of Burgundy. And I was raised in Dijon, but I made most of my studies in Paris, in fact, after that.
And looking back, how do you think your parents shaped your thinking about the world?
Oh, my parents were both of them teachers, and so they teach me a lot, of course, and they have given me a clear vision of the world, I think.
And when did you... Were they responsible for your developing an interest in science and engineering, or did that just come through your school?
It's always difficult to say because, of course, there was a lot of magazine scientific magazine. They were both professors of physics, so it was clear that I was raised in a knowledge of, let's say, of scientific, and so part of it, of course, come from there. Part of it come from the fact that when I was a student, I was better in physics than in other matters.
So around the dinner table, was there discussion of physics problems and students, or that was kept out?
No,
yeah.
It was kept down. No. We had very lovely discussion in dinner table, but it was more on society problem than on physics.
And was it a political family?
No, not especially political. No, but okay, they were interested in most of the problem of the society, and they were discussing. We were 5 children, so in fact it was quite lovely.
Yeah. And then in terms of your schooling before you went to college, were there teachers who got you interested in science?
Sure.
And then where did you go do your undergraduate, your college work, and what did you focus on?
I was in Paris after that, and I made what we call class préparatoire, which is the way to enter the grandes écoles. You know, the French system is a very specific one. We have grandes écoles for engineers, and so I entered the École Centrale, which is one of these schools for engineers, and I made 3 years in this school of engineers, and then I specialized in reactor physics and made a doctorate in Orsay near Paris.
And what was the turning point in your deciding to go into engineering, into nuclear engineering? Was it that there were opportunities at that time, or was it just that the problems excited you?
No, I was interested by the problem for a long time. In fact, I was interested before the end of my college studies. I was interested by the problem of atomic energy in a general way. It was the beginning of most of the application at the time, and it was in the 50s. So I was really interested, and I made all my best to enter this field as soon as possible.
Right. And I'm curious, I guess you would classify yourself as a scientist engineer. Yeah. And so what I think our audience out there would be interested in what you think what are the skills in engineering that a student contemplating the career should understand that he's going to need to have or acquire over time in the course of his education?
I think that the most important is the understanding of the problems. And in fact, we can learn a lot, and of course, during all these college years, we learn a lot of things about mechanics, materials, chemistry, and so on. But at the end, what remains? Only what you have understood. And it's the same with scientific studies. I mean, when in the engineering school at this time, there was no specialty in nuclear. So the only way to get some nuclear knowledge was to go to the university and to complete the formation, let's say, with diploma from the university. And it was the same. At the end, what you have understood, you keep it in mind. The rest is forgotten. You can find it in book if you read, but it's not the important point.
But is there some learning that you have to do about the way you approach a problem?
Yes, sure. I would not say maybe it's not learning, it's training.
Training, yeah. So
experience. You should be experienced. And one of the merits of these schools, of this college, are the fact that you have a lot of training in small groups in order to learn how to manage a problem, how to understand a question and to try to find the right answer and so on. So I think it's quite important that.
And I guess in your field, when you're on the cutting edge of new processes, it's working with groups. And also working with international groups, because this is an international community, and as we address the problems going down the road, so collaboration is very important.
It has been a remarkable situation for nuclear, because at the beginning, of course, it was national problems, national security, and so there was, of course, as you said, a group work. We never work alone in this, in this kind of field. It's too complex to get progress if you work alone. So we work with others, we work in groups and so on. But at the end, it was important to exchange with others, and it has happened quite soon. When I started to work with in the nuclear, in the Commissariat Énergie Atomique, very soon it was open to possibilities to exchange with, not with all countries, but already with a lot of countries. So I mean, very soon we have started to organize not only exchanges, but cooperation on some particular topics and so on. And after that, of course, it has been growing and growing. And now I would say that practically all the developments are made in international cooperation.
Now, what also, before we actually talk about the work of your commission and the role that you have played over the years, I'm curious about the question of creativity and how you see it emerging in the context of what we just discussed.
It's a good, difficult question. Difficult question because, in fact, I think that creativity is not everywhere. I mean, some people have a real gift for creativity, and very often they are not the best in other fields, but they have the possibility to bringing a new idea, to saying, okay, but why not to go there? Why not to go there rather to go always the same path? And I think that this kind of gift is not for everybody, but those who have that are very important in the process. And as it's once more, it's a work of groups, a work of cooperation. Those people with this particular gift are giving the, let's say, the idea to the group, and after that it goes quite easily.
And I guess that the challenge that the environment outside of the technical setting that is presented is very important for creating a challenge. I noticed that yesterday in your talk, you were talking about the impact of the oil crisis, the first oil crisis on France, and you used the phrase "no oil, no gas, no coal, no choice." So in an organization like yours, that poses a challenge, and that is very important.
Yeah, we have to take into account several factors which are not at all scientific or technical. We have to take into account the kind of political decision we were referring for this decision of building a big amount of plants to face the oil crisis. But we have also to take into account the public acceptance, for instance, problem, which are quite surprising sometimes. If we take the problem of waste, the reaction of the public on the problem of waste are not understandable from the scientific point of view.
In the sense that the problem is one that you can manage, but the public attitudes are anywhere from, are very. Tell us a little about the commission and its evolution over time. I know you have held, and I couldn't do justice to your career, but you have held many important positions, including head of the Nuclear Energy Division and head of reactor department, and so on and so forth. What does the CEA do in France?
In fact, CEA was created more than 60 years ago now, and it was created to develop all the application of atomic energy, let's say. It was said like that at the time. And all the applications, that mean that it was to create, in fact, industry for some of these applications, in particular for nuclear energy, but not only for nuclear energy, for all the applications, for instance, of nuclear techniques in the medicine. There have been, as you know, a lot of applications,
cancer
examination, cancer treatment, and so on. So, I mean, all these was in the mind of the people who have created the CEA, and the real challenge has been to create all these applications and to keep the organization in its role, which is, in fact, to develop R&D, let's say. The role of the CEA is to make R&D in all the directions which are needed, but to make R&D.
Research and development.
Research and development. And each time it was becoming some kind of industrial application, we have subsidiarized. We have created a subsidiary. We have created a company.
I see.
Separate
that
from
goes private?
Which some of them goes private, some of them remain in the public domain. For instance, the biggest one which has been created has been COGEMA, which was a company created from all the production activity of the CEA, production of materials, processing, enrichment, and so on. And we have created COGEMA, which becomes Areva now. It's Areva. It has been created from a part of the CEA when it was obvious that it was no more R&D, it was really industrial business. So we have created that. We have created a computer company, a very big computer company, because at the beginning, as all the organizations working in this field, we were obliged to create our own computer, at least all the computer codes, even some hardware in some cases. I mean, so we have created a company for computer application, let's say computer codes. We have created companies for biology application in radioisotope production and so on. I mean, a lot of companies. So the CEA itself is still has remained R&D, and the R&D in various directions. And of course, this kind of research organization develop its own activity. You know, the research is, by definition, is creativity, as you mentioned. Creativity, you create always something. So, for instance, we have in CEA, of course, we have the part of the research on nuclear energy, which is going on, and which is still very important. The part of the research on defense application, which is also quite important. From the biology part of the research on biology, the research on biology was necessary for two reasons. First one, because we wanted to know the risk associated with nuclear application in general way. Also because, as I said before, the application of nuclear technology to biology was quite important. So this biology department of the CEA has been growing and has been creating new activity which were not directly related to for instance, the best knowledge on the MATCO problem was in the CEA. MATCO problem is not directly related to nuclear application in any way. It's the same for physics. Fundamental physics. We have the most important astrophysics laboratory in France.
I see.
Because in fact it has been created from at the time when we have changed for astrophysics. We have moved from telescope, let's say, learning to radio emission learning, and so.
So what you have been a supervisor in these operations at various levels, and so what is that task? It would seem to be enormous because in a scientific enterprise, you always want to have the openness for creativity. You clearly, at certain points, problem emerge within problems, as you've just said. And then in addition, as we said initially, sometimes the state has an agenda that because of national security issues. Talk about those challenges.
No, I think it's quite important. In fact, as we said before, it's a work of a group in general. So we started to work on some particular problem. For instance, when we have, for instance, decided to move to light water reactors in France, it was not the first. The first development has been on natural uranium reactors because we had no enrichment at the time, and so we had So we have decided to move to light water reactor. We have said, okay, we will organize the R&D in such a way that we can rapidly take all the right decision in this. As it's the work of a group, you always need someone to lead the group, to orientate, to say, okay, we work like that. So it has been rapidly my job. In fact, I've been working, let's say, 10 years on research itself, making research on experimental research, mainly on nuclear physics. But very rapidly after that, I became, in fact, a manager of group. Managing this kind of activity. At the beginning, it was managing the research of a small group on a particular topics. After that, it has been expanding, and when it was expanding, of course, the problem you mentioned, the interference, let's say, with the outside, with other problem, political problems, financial problems, and so on, becomes important, and progressively, it was the management not only of a group of a particular program, but it was the management of all the sector of activities.
Now, France is a country that, on the one hand, has made a long-term commitment to nuclear power, and on the other hand, has made maintained a robust nuclear deterrent for national defense. Have these two programs interfaced a lot over time? Talk a little about that evolution, or are they completely separate?
No, now they are completely separate. They have been interfering in the past when it was necessary to produce materials for the, in fact, the interference was there, the production of materials for the defense application. Production of enriched uranium, production of plutonium for application. It's clear that it was interfering because at the beginning there was limited knowledge, and for instance, the first enrichment plant has been done to fabricate enriched uranium for weapon application, and then the same technology has been used for civilian application. So I mean, the interference was in fact that it was practically the same technology which was used at the time for both applications. Now it's completely separated for two reasons. The first one, because we have completely stopped the production of materials for military application. We consider our existing stock is sufficient, and we let run on the stock. But also because even if we were deciding to restart, which is not the case, but if it were necessary to restart production, it will not be with the same technology as we are using for civilian application.
So there would be a few.
It would be completely different.
Yeah. Now I know at a certain point, France's deterrent was confronted with the problem of the comprehensive test ban treaty, which you were a part of, and I know you were a leader in moving the deterrent to simulation models, which could then make it possible for France to abide by that treaty, and it was a signatory. Talk about that as a problem. I'm not asking you to get in technically, but what sort of a challenge did that pose, and then talk to it about so that it can help us understand the work you do. Yeah.
To try to be simple on that and not too much on the confidential part. Let's say that the problem was clear. At one time, we have decided that we don't need to create new weapons. The existing ones are sufficient for our what we need in terms of deterrence, and so we said, okay, we don't need to create new weapons. The only problem, we need to maintain the existing one and to copy them. Let's say when they will be to hold, to keep them safely, we will create new ones which are copy of those old ones, and so we have said. To do that, probably we can rely on simulation. We can rely on modeling. We can rely on modeling with two conditions. The first one, to have a set of experimental data which is clearly established and which could be used for a long-term application. And when it was decided, it's the reason why we have added a few tests to what we had before, just to complete our set of data. And the second condition was to maintain not only the weapons, but also to maintain the competence of people. Because, of course, you need to be sure that if you copy, for instance, or if you maintain a weapon, or if you copy it to renew it, let's say, you need people to confirm that it's the right way to do it. So the modeling has been organized around that. We have said, okay, we will develop large computer in order to be sure that we model sufficiently in detail the behavior of this machine. But in addition to that, we will also create experiments sufficiently close to the physical problems we are treating in order to train people. Because, of course, people are also aging and they will have to be renewed, and the people who have known the test will not be there in 20 or in 30 years from now. So we need to train new people, and it's one of the reasons of the development of the large facilities, technical experimental facilities. In particular, we are completing now a big laser which is similar to the NIF. You know the NIF in Livermore, the National Ignition Facility in this country. We have practically a similar machine which is being completed in France.
And this is probably a case. Well, there are two interesting things here. One is that the program adapts to new international values, in this case, the comprehensive test ban. But also, I would imagine there is collaboration with other countries, you know, in the alliance who basically are confronted with the same problem.
Yes, but the collaboration is limited. Nevertheless, it's limited to knowledge, let's say, general knowledge.
Right.
It's not cooperation on the weapons themselves, of course.
No,
completely.
Right, yeah.
It's not cooperation on the technical problems too much in detail, but it's cooperation on the knowledge. For instance, yes, we are for this laser, for making fusion experiments on laser, we have cooperations, clearly.
Now, by adopting and going full blast into a nuclear power program, France is positioned to really address the challenges posed by climate change. Let's talk about that. Give us a sense of the general environment that we now confront globally with regard to the recognition of global warming on the one hand, the rise of emerging countries, the sources of our electricity, and so on. Give us a little background on that.
Oh, yeah, sure. Today, the electricity production is an important part of the energy consumption, more than a third, near 40% of the energy consumption in the world. And the electricity production is easy to manage, let's say, in terms of we know where are the plants. The plants are well identified. Most of them they are reviewed quite often. Let's say even.
This is the electrical plants.
The electrical plants, yes.
Yeah.
So. Our thinking is that the electrical plants is the place where we can easily, at least in the speech, easily move in order to reduce the greenhouse gas emissions. In France, we have the chance that, and it's a chance because it was not the aim at the beginning, but we have the chance that the nuclear plants supply more than 80% of our electricity, so that our emission of CO2, emission of greenhouse gas, is very, very low. Mm-hmm. But in other countries, it's not always the case. And in particular, on the world side, if we look to the situation worldwide, more than 40% of the electricity is still coming from coal-fired plants. Mm-hmm. And coal-fired plants are the one which emit most important amount of CO2. Mm. So this is a very difficult problem because those coal-fired plants in a large part are in developing countries. Mm-hmm. And developing countries, it's not so easy to move from what is for them the most economical solution in the short term to a solution which can certainly be better from the point of view of the climate change, but which could be more expensive or more difficult to get. So I think that the problem is really there. And
here we're talking about a country, for example, like China, where it's pollution as a result of its need to turn to coal is quite apparent.
Yeah, but of course, China is opening a coal-fired plant every week. Mm-hmm. And so it's growing very, very quickly, mm-hmm. and it will not make easy to reduce once more the carbon emission around the world. Mm-hmm. But China is not the only country. I mean, there are also U.S. is burning a lot of coal. Germany is burning a lot of coal. I mean, there are still there are still many countries which could and which should, in our view, move progressively to reduce the emission of carbon due to the electricity production. After that, there is other problems. The cars themselves, transportation in general way. There, of course, the situation is more complicated because there are a lot of millions and millions of cars around the world. So to change everything will not be easy to do in short term. But nevertheless, we see, for instance, a general trend today to say, okay, probably electric cars with battery, reloaded battery, and so on will probably be the solution in the future. It will take time, but it will be a solution.
So in the case of electricity, it's very easy to quantify how much the world is using, how much the world will need in the future, and to identify the source of a lot of that electricity being coal, and then we can then link that to what we clearly see now as the carbon emissions and the impact on the global warming problem. Now, let's think out loud about both the challenges and the opportunities if this becomes a way to address the global warming problem. Now, at the first level, it's a political problem. And it would be interesting for you to compare, for example, France to the United States to China with regard to what is it that makes possible or prevents the move toward nuclear power. France and the U.S. What's the difference there?
I think once more you recall the fact that in France we had a particular situation because we have no fossil fuel. So the fact we have no fossil fuel has made easier the political consensus to move to nuclear. very often the political consensus is lacking. So when, for instance, in Germany, there is no political consensus to replace coal plants by nuclear plants. So they are looking to any other solution, but they have not the possibility to do it today. So there is this problem of political decision, which can be or cannot be according to the existing other solutions, other possibilities, which can be or not more easier, let's say, to take it. The second point is the financing. Because we need, of course, a capital investment for nuclear, which is quite important. The investment is the most important part of the cost in the case of nuclear, as for the renewables, by the way.
And this is, in both the case of renewables and in the case of nuclear power, it's a heavy capital investment up front.
Yeah. It's a heavy capital investment up front, and in the case of nuclear, in addition to that, it's a long time of investment because it takes several years, till 10 years, to build a nuclear plant from zero, let's say, to the operation. So this is a real barrier. You mean, even if after that it's a very interesting investment, if you have a very important revenue after that, you need to spend money during 10 years, with some risk, of course. There are always some risk. With some risk, you spend money, a lot of money during 10 years before getting any kind of revenue. And I think that this kind of difficulty is appreciated differently according to the countries. And in particular, I think that for what I see, I'm not a US citizen, but from what I see from France, I have the feeling that it's one of the difficulty to restart the construction in this country, to overcome this problem of the investment.
Now, political attitudes in democracies are very important. So if we look at China, clearly, and their needs, and the enormous social problems and the size of China and so on. So in both the case of France and China, is it fair to say that the state is more insulated from, I'm not saying that France is not a democracy, but France does have a history of having a state that is important, in the way the U.S. Does not. So in America, we see that public attitudes, I'm thinking here of the whole 3 Mile Island phenomena, the Jane Fonda movie and so on. I mean, that had a real impact on a whole generation of people in the United States on the one hand. But in the case of France, where I don't even know what the political attitudes are, but it's easier for the state to move ahead. And of course in China, where you have no democracy, where you have a communist party, then it would seem that it's a natural solution for them.
Okay, you're right. There are differences due to the political system. In particular, in France, it's clear that we have a centralized system, which is quite efficient for some things, but of course has its own drawbacks. No, I think nevertheless that it's not, today, personally, I think it's not the main problem. It has been at some times, but today, facing this difficulty of climate change, facing a lot of problem, crisis, economic crisis, and so on, people are more conscious, I think, of the reality of the problems. And I was surprised many times looking to polls. The polls in France are not very much in favor of nuclear energy. I don't think so. It's always difficult to get a majority in favor. Very often it's a very small majority in favor of nuclear energy, in spite of the benefit we have with this electricity, cheap electricity, and so on. In this country, in the US, I have been surprised to see that the polls now are very good in general way. People are in favor of nuclear energy. So it's I think the obstacle you mentioned, the obstacle of the democratic discussion, debate about, and we had a lot of debates about the nuclear issues. I don't think today it's a real obstacle. And in China, there too, I think that there is a problem of financing, of means. But today, facing this difficulty of climate change, facing a lot of problem, crisis, economic crisis, and so on, people are more conscious, I think, of the reality of the problems. And more than a problem of political obstacle or political. They have decided to restart construction because, as you know, China has started construction of nuclear plants at the end of the 80s. After that, as all the other countries practically, they have slowed down this process because of the very low price of the oil and gas. Mm-hmm. And now they are restarting because they are facing a real difficulty with the expansion and with the fact, as I said before, that they are opening coal plants every week, which is very. I think that Chinese responsible are conscious of the difficulty, are conscious that they cannot play with that for a very long time. It will be very difficult to accept that China becomes the most important polluter, let's say, in the world. So, I mean, they have restarted the nuclear construction, and they are making today a very strong effort to build nuclear plants.
Now, as you move into the future, where you have this open debate, let's talk about some of the problems and opportunities here. So in terms of the fuels that you need for the nuclear plant, the virtue of uranium is that it's widely distributed, and there seems to be enough, at least, for this century. Talk a little about that, because obviously the trouble with oil has been that it's located in very politically vulnerable places.
No, it's clear that there are three advantages with uranium. The first one is that, as you said, it's distributed. There are uranium practically all around the world, and the main producers are very diverse. Australia, Canada, Kazakhstan, I mean, completely different countries from different horizons. So I think the first advantage. Second advantage, you can store a lot. Mm-hmm. You can buy 5 years of uranium in advance. It's a small amount you will put somewhere in store. So I mean, you can pacify, let's say, the market by such storage. And third advantage, the cost is sufficiently low that even if there are difficulty with the market, the cost will increase. It has been the case 2 years ago because, in fact, the Russians have stopped to export large quantities, and so the market has been facing the difficulty for short term, but facing the difficulty that there was more demand than supply. But even if the price of uranium double, or it will be a very small change in the cost of electricity, because the uranium is only 5 or 6% of the cost of nuclear electricity.
Mm-hmm. Now, of course, the other issue here is safety, and as you move from one generation to another of reactors, and this is a problem that everyone is conscious of. It must impact public attitudes. So what has been the evolution there in terms of dealing with the problems of safety?
I think there have been several evolutions. The first one, of course, the utilities and the makers have rapidly taken lessons from the accidents, in particular from 3 Mile Island, which has been the most important, let's say, in terms of technical lessons, because we have learned a lot from 3 Mile Island. So, in fact, the improvement needed to avoid such an, or at least to reduce very low level the probability of such an accident, has been taken very quickly after 3 Mile Island. Then there have been a second step of improvement, to be short, with what we call now the third generation of reactors, which has been to say, okay, we have been decreasing the probability of a severe accident. We have been decreasing it very low. We are around 1 million a million a year to have such an accident for a reactor. Nevertheless, even if it's very improbable, we will take into account the consequences of such an accident in order to avoid to disperse radioactivity around the plant and so on. So even if there is a very severe accident, there is a very, very low probability now, it will be contained inside the plant itself. So it will be a problem for the plant, of course. We will lose the plant, but it will not have important consequences around the plant.
And in your country, you part of what you've done is you've standardized all the plants. So all of your plants are safe. So as you're improving safety and through research and theory, then you're implementing that across the board. I guess it seems to me there are two political problems here. One is what should be our concern about the ability of a country as it's facing economic crisis to continue to keep the safety up at the highest levels. So that's really the first question, because one sees, even at a university, the deterioration, in the face of an economic crisis and so on. So what I guess what I'm saying is the risk increased, by the sometimes inadequacy of democratic polities to maintain the highest standards.
Sure, it's quite important. We have always in mind two things. The first one is that safety requires what we call a culture. We are training people. Culture. Yeah. The culture of safety is quite important in this business, and it's important at all the steps. I mean, it's important for the R&D. It's important for the R&D for two reasons: because we are creating a new process, but also because we are making experiments and so on. So, okay, it's important for building a plant. It's important for operating it. It's important for the dismantling and so on. So, I mean, this culture of safety is our first concern. At all the levels, and I can say that that, for instance, the utilities have a world organization. There is a World Association of Nuclear Operators. They are always looking to that, to be sure that all the operators around the world are keeping sufficient good culture. And the second point is to have always an independent safety authority, to have somewhere a commission where people are able to ask you, what are you doing there with your plant? Is it correct to explain what you are doing, and we will give you a license and so on. So this is permanent checking, permanent control of the operators, of the makers, of the research and so on is quite important.
Now, it's interesting here because with nuclear power, you immediately move global as we become very clear, and so I guess the question becomes how other countries are situated to deal with the implications of responsibly, using nuclear power to deal with the climate change problem. And you mentioned the training of personnel as one. So I guess in international politics, we know there are countries with a lot of money that may not follow through. And so what should be our concern about that as, let's say, emerging countries with not the history of a state, of training, of an educational system, that are really just buying the plants off the shelf to maintain the high standards that a country like France and presumably the United States could maintain?
It's one of the important problems which is on the table now, because you're right. There are 30 countries which are operating reactors for a long time now, and they are organized between them, and we can be sure that all these 30 countries are working correctly because of all these checking, all this cooperation. But now there are a lot of new countries which are considering the possibility of entering let's say, the production of the nuclear power production. And there is a lot of discussion presently at the international level, in particular through the International Atomic Energy Agency in Vienna. We are discussing how those countries could accept, because it's a problem, accept international agreements in such a way that everybody can be guaranteed, let's say, on the quality, on the safety, on the non-proliferation, all the important issues which are related to this nuclear power production. So, in fact, the idea today is to say, okay, we have some rules. The rules we are applying to ourselves. The 30 countries which have already planned today applied some rules. We would like to have those rules recognized on an international basis, either by some kind of treaty or by some other way to organize it, and in such a way that we will be sure that they will be applied for new countries. A country, as you said, which has money and want to buy a plant, first of all, they should create a safety authority. They should train some people for this and that. They should take accountancy of materials and so on. I mean, there will be obligation for the countries. And the way we are discussing today is how to make those obligations, those commitments in international legislation, international laws.
So this is interesting because we then see another set of problems, which is the relation of the transfer of nuclear technology for nuclear power to deal with climate change, and then the problem of nuclear proliferation, where the wrong states, some would say, shouldn't be given nuclear weapons on the assumption that they wouldn't be deterred and they would actually use them, which may or may not be a mistake. So I guess the problem, what I'm interested in is how science and the kind of experience that you have can contribute to preventing the nuclear power becoming a vehicle for proliferation, basically, and how the community of nations can work together to say, okay, Iran, you can have a nuclear power, to supply electricity on the one hand, but on the other hand, the international community feels that you should not have nuclear weapons or use this. So I guess the first question is, can we ensure that if you move down this nuclear power route, it won't become an opportunity to obtain nuclear weapons?
You're right. The problem is not clear. It's not simple for two reasons. The first one, because proliferation is not directly linked to nuclear power. I mean, a country which has no nuclear power can start to proliferate and start to build some materials to make weapons without Pakistan, for instance. Yeah. Okay. So this is the first point, first difficulty. Second point, which is in the other way, I would say nuclear power, when a country has to enter the nuclear power production, automatically they are obliged to sign agreement with the international agency we ask them to sign the NPT if it's not the case. No, it's the case for most of them. To sign agreement for control of. So the important issue is that as soon as they enter this nuclear power production, they will be controlled, which is not the case for the countries which have no power. A country which has no nuclear power is not controlled. A country which has nuclear power will be controlled. It's quite important because if you control, you detect more easily an activity which is not the one we want to see. So this is another point.
And control means here that they're being watched?
They will be watched. They are obliged to declare what they are doing and so on. Yeah. And so it's kind of security for the other country. Third point, nevertheless, we should be sure that the technique itself is not, that nuclear power technology does not help for proliferation risk in any way. So there we are very selective. We said, okay, today if a country wants to build one nuclear plant or two nuclear plants, we are ready to offer them the possibility to building light water plants, as we are using in most of our country today, because those are safe. And the risk of proliferation with a light water reactor plant is very low. You cannot do anything very interesting for proliferation. You cannot produce good plutonium. You cannot make okay. So this is clearly a technology. On the other hand, we don't want these countries started to make enrichment or to make reprocessing with the existing technology. They are too much sensitive. It's too much easy to move to other applications, let's say. So and we say, okay, there is no reason. It's a debate for Iran now to say there is no reason to build an enrichment plant if you have only 2 or 3 reactors. An enrichment plant is for 50 reactors today. At least 50 reactors, no more, not less. So there are a few enrichment plants around the world. They are sufficient. If for some reason there is a need for a new one, there are still someone in construction in the US or in France or in Russia or elsewhere sufficiently diverse to get, and we are ready to give a guarantee of supply of the enriched uranium and so on.
So in the end, this is, in terms of nuclear power, it seems clearer when you have a place like France, where one doesn't have to worry about the clothes and so on. But what you're saying is that there are a whole set of problems that arise when you go global with this. And here you're going to have international cooperation. You're going to have, states like Iran are going to have to make a choice, about whether they want to be upfront about what this is really about. Now, I'm curious. Oh, sorry. Go ahead.
No, I'm just picking the fact that international cooperation is two modes. I would say we need international cooperation on the legal aspect, let's say, on the control, on the organization, what is acceptable and not, and so on, international rules, and we need international cooperation on the technique. Because the development of new technology is absolutely necessary, in particular to get more resistant to proliferation. And it's one of the main criteria, main objective we have for this Generation 4 in the Generation 4 International Forum. That
where you're discussing new reactors.
Yes, we are discussing new reactor, new cycle, new system, in such a way that they will help, of course, for the saving resources, waste minimization, and so on. But also they will help us to have more resistant to proliferation system.
And I guess the next question we have to raise, and this we're coming to the end of the program, and that is, how does a post 9/11 world change things? Because terrorism, although Europe had experience with terrorism, after 9/11, there's a new sense of vulnerability of what terrorists can do. The regulatory commission here is doing studies now about how secure from an airplane attack facilities have to be. How will that is the post 9/11 world, does it pose a new set of challenges, or are these challenges that have already been factored in the evolution of programs such as France?
Of course, it has been, even if it's not new challenges, it's a new experience, I would say. Unfortunately, we have events such as 9/11, other kind of events are also earthquake, some big earthquake or tsunami and so on. All these kind of events, we learn something, and we learn that we learn in particular one more aspect of the safety. The safety for nuclear plants, it's not only the risk associated to the operation of the plant itself. It's also a lot of external events which can play an important role for the behavior of the materials and of the plant itself. And in particular, I mentioned earthquake because external events are most frequent, let's say, is earthquake, but you have also the risk of terrorism. You have the risk of a lot of external possibilities. We have a problem with the wind. We have a problem with water. We have a problem with, a lot of external. So it's part of the safety studies, and each time there is a new kind of event. Of course, we learn. And the problem of the airplane attack, let's say, of a plant has been on the table now since the 9/11 event. And it's clear that the safety authority has asked the operators to look to what could be the consequences and to find some way to limit the risk. And to limit the consequences for the residual part of the risk, let's say. So I think it's quite important problem, and of course it has not yet been taken into account in the design itself, because the plants were either existing or ready to be constructed, so it was not bad. It's for the existing plant or for the one we are constructing now, measures have been taken, and for future, the design will include this kind of concern.
So in the end, as we confront climate change, I guess the argument would be that nuclear should be part of the mix, not the sole thing. And if we're going to move that way globally, then we have to really be concerned about safety and about international politics being able to ensure that safety.
Oh yes, we are ready. You are right. We consider that nuclear is one of the solutions. Unfortunately, we have not too much solutions, so we have certainly to develop all the solutions. And of course, renewables, each of them with different kind of application. I think renewables are important. Nuclear is important. Better to replace coal by gas each time we can, and so on. All the solutions will be needed. And for what concerns nuclear, I completely agree. Today, we should be fully international. We should organize everything, thinking that we are not alone in the world, that we need to cooperate. We need to cooperate on the legal issues. We need to cooperate for peace. We need to cooperate for technical improvement. We need to cooperate on all the aspects. And it's an important issue. And I'm very pleased personally to see that the progress which has been made. The time I've been in this job, I've been more than 40 years in the nuclear business now, and I have seen the improvement of this international, let's say, cooperation around the world about all the problems related to nuclear, and I'm personally very confident in the future.
Dr. Bouchard, on that note, I want to thank you very much for coming on our program and sharing with us the French lessons with regard to nuclear power. Thank you.
Thank you.
And thank you very much for joining us for this conversation with history.